In today's class, we are going to study magnetic effect of electrical current. This is second chapter of the physics of class 10th. The magnetic effect of electrical current. To explain the term, let me tell you right at outset. The only meaning is if you have an electrical conductor and you make electricity to pass through this, then this electrical conductor will develop a magnetic field around itself and will start behaving like a magnet. That is the only magnetic effect of electrical current. That if a conductor is made to pass through itself electricity, that becomes a magnet by developing a magnetic field around itself. So that is magnetic effect of electric current, and throughout the chapter we will study about this. Right at outset, let us first define some of the terms which will be very frequently used in this chapter. So first will come magnet. So magnet, you can say magnet is an object which is able to attract towards itself other substances like nickel, chromium, iron and steel. In case of steel, some people have doubt. See, magnet definitely is able to attract steel towards itself. What it does not itself attract towards itself is stainless steel. So usually the articles that we have in our houses are made up of stainless steel. Steel is definitely attracted by the magnet. So magnet is an object which is able to attract other objects like nickel, iron, chromium and steel. And these substances are called magnetic materials, and they are called so because they are attracted by the magnet. Now another point that we need to explain will be coming north pole of a magnet. A magnet is having both poles, north pole and south pole. Time and again we will be using north pole, north pole. So let me explain what the meaning of north pole is. Even before we were knowing, not knowing rather, even before it was known to us that earth is having magnetic field, before that itself we nominated one pole of a magnet as north pole. So the definition goes like this: that pole of a magnet, that pole of a freely suspended magnet. A freely suspended magnet, to assume this, say it is tied with a thread and it is free to move if something is there to influence. If some force of influence is acting on it, it is free to move and it is held. Freely suspended magnet. Freely suspended magnet. That pole of a freely suspended magnet which always points towards the geographical north is called as north pole of the magnet. That pole of a freely suspended magnet which always points towards the geographical north of the earth is called north pole. Another pole obviously will be south pole. Now there are two more small informations regarding poles. And first let me tell you, okay, it is not possible for us to have an isolated pole. Suppose you have a magnet and this is having north pole and this is having south pole. If you cut it from here, this part will develop south pole and this part will develop north pole. So it is not possible for us to have an isolated pole. If you have a magnet, it will have both the poles. North pole also it will have, south pole also it will have. Now like poles repel each other. If you have two poles like north pole and north pole, they are said to be like pole. If you have south pole and another pole is south pole, they will repel each other. And unlike poles, if one of them is north, another is south, then they will attract. So we have come up to here. Unlike poles repel each other. Now the term magnetic field is to be defined. So for defining magnetic field, we'll go like this. That if I make a magnet here, let us say that this is the magnet. This is north pole. This is south pole. So when we say magnetic field, that means the space surrounding a magnet. This is magnet and it will have some space all around 360 degree. It will have in this axis, it will have like this, it will have like this, and above the board and below the board also. So there is some space around the magnet where the influence of this magnet can be felt. That is called magnetic field. So to say more precisely, magnetic field is the space surrounding a magnet where it means magnet's influence can be felt. That is called magnetic field. Now magnetic field lines. Magnetic field lines, these are imaginary lines, and to define them, let us say that the magnetic field lines are the lines along which a north pole would move. If I keep a magnetic compass here, magnetic compass is nothing but a small magnet. This is one magnet, that is another magnet. That magnet will have north pole, it is having north pole, and since I am keeping it near to the north pole of this magnet, so it will repel. The north pole of the compass will point in direction which is opposite to this. It will repel it. Now like this, if I keep going, drawing a line, so if this pole is free and this force of repulsion is strong enough to push it, so like this it will start moving. Up to some extent this will move it. Thereafter it will getting start attracted by the south pole. So it will take a journey like this. Now this line of journey along which this north pole has moved from north to south is called magnetic field line. Once again let me tell you, a magnetic field line is an imaginary line. It is the line along which a north pole would move if free to do so. Keep north pole, that is magnetic compass, near to it. This being north, it will repel the north pole, that will point other side of that. Then keep the compass further away, and like this if we keep going, a line will be drawn like this. These lines will be are along 360 degree of the magnet. So these are called magnetic field lines. Now comes the question, magnetic field direction. What is the direction of magnetic field? This is little difficult to understand. Rather, I have just told it is not at all difficult to understand. The magnetic direction of magnetic field, in three different ways we will tell you. Say as this is a magnetic field line, and if I want to find out at this point what is the direction of magnetic field, this is field line, and at this point what is the direction of magnetic field. So I must tell you in very simple words, you can say the direction of magnetic field is the direction in which north pole or north end of a magnetic compass will point when kept at that point. If I want to find out the direction of magnetic field at point A, then I will keep the compass at point A, and the direction in which the north pole of this magnetic compass points, that is the direction of magnetic field at this point. In little bit complex words also this has been stated, and then that is stated like this. The direction of magnetic field at a point is the direction of the resultant force acting on the hypothetical north pole when kept at that point. It is exactly same what has been said earlier, but hypothetical north pole, why they have said hypothetical north pole means imaginary north pole. See, you cannot have single isolated pole of a magnet. So it is said so, okay, if let us say it is possible for you to have a north pole, keep the north pole here, and then all the resultant forces will act, and there will be a direction of the resultant force. There are numerous forces that must be acting on it, and finally the resultant force was acting. So the direction in which the direction of the resultant force acting on the hypothetical north pole when kept at that point is the direction of the magnetic field. Another way of defining the same direction of magnetic field is that at a point along a line, if you want to find out the direction of magnetic field, it is the direction in which the tangent points to when drawn at that point. Say as at point A, this is the line, and you draw at point A, you draw a tangent. So direction of magnetic field will be along the tangent to this point. Direction of magnetic field at point A is acting along the tangent drawn at this point to this magnetic field line. So this is how we could say what is the meaning of direction of magnetic field. Now further we will study how to draw magnetic field lines and what are the characteristics of magnetic field lines. That we'll see in the next class.